All right. So we're into number 38 and 39. And it says, how many distinguishable permutations of letters are possible in the word Mississippi? I first want to go over what does distinguishable permutation actually represent? So let's write it down here in our notes. So a permutation, even in other courses such as a modern algebra course, does refer to some sort of order and how you can arrange things or you can choose things or when you're mapping things. So we know permutation means the order matters, but we have the word distinguishable permutation. So that comes a little bit more different than a regular traditional permutation and counting techniques. So I want to write a little synopsis about what I mean by distinguishable permutation. A distinguishable permutation is the number of ways n items can be arranged when items are distinct from each other. So distinct means different. So they're different from each other. But are considered to be identical in their subgroups. Subgroups, not in a modern algebra way, just use the word subgroup in terms of its English word in this case. So, for example, when we see the word Mississippi, we have to, it says permutation, so that means we have to arrange the letters in the word with respect to its order. But if you notice, there are certain letters that repeat, and those letters are considered identical to each other. So the letters are distinct themselves, but when you look at a letter in the group, such as in the S's or the I's or the P's, they're considered identical within their own group. Because if you reverse the order of the first S with the last S, you can never be able to tell because those S's are identical. They have the same functionality. So, in this case, I write my formula a little bit different than other people write their formulas, but it doesn't really matter. We can say define the number of distinguishable permutations. It is n factorial divided by k sub 1 factorial times k sub 2 factorial all the way to k sub m factorial. We're going to go in a sequence where I want to say that k sub 1 plus k sub 2 plus all the way to k sub m equals to n. All right, so for number 37, I believe, 38, my apologies, we want to find the number of distinguishable permutations when it comes to the word Mississippi. The word Mississippi has 11 letters, so n is going to equal the total number of items and that equals to 11. So to find out the number of ways we can list 11 items in a specific order, and once again, you can't repeat in this case because you're using the word Mississippi. So that means if I have 4 S's and I take 1 S, I have 3 S's left to be placed. We can call that the permutation of 11, choose 11, or that just equals 11 factorial. And 11 factorial, when we compute it, we're going to use our math calculator. So 11. If your calculator has a PRB button on it, locate the PRB button. For graphing calculator, we're going to go over to math, then PRB. Click on the fourth option, hit enter. That is going to be 916,800. That is how many ways we can use the letter in the word Mississippi to organize our codes. But that's not our answer, because as I said before, there are letters in the groups. There are letters in each group that are considered identical. So K sub 1 is going to equal to the number of M's in the word Mississippi. And that is going to be only 1 M. So K sub 1 equals 1. So to find K sub 1 factorial, that's only going to equal to, I'll put multiplication here, equal to 1 factorial, which equals to 1. Then K sub 2 equals to the number of I's in the word Mississippi. Number of I's. And there are 4 I's in the word Mississippi. So K sub 2, oops, I forgot my sub 2, is going to equal to 4 factorial, which is 4 times 3 times 2 times 1. That is 24. K sub 3 is a number of M's in the word Mississippi. And there are, sorry, not M's, number of S's, excuse me. And there are also 4 S's in the word Mississippi. So K sub 3 factorial is the same as 4 factorial, which is 24. And last but not least, K sub 4 equals to the number of P's in the word Mississippi. There are 2 P's. So K sub 4 factorial just equals to 2 factorial. Look at 21. Let's rewrite that. 2 factorial, and that equals to 2. Because it's just 2 times 1. I'll write it out. 2 times 1, which is 2. Now we have all the information we need to answer this question. How many distinguishable permutations can be formed using the word Mississippi? So that's going to be 11 factorial divided by 2, well, rather, not 2 factorial, but we can't skip the 1 factorial. 1 factorial times 4 factorial times 4 factorial times 2 factorial. Hopefully you can see that my 11 factorial is for n. And then these numbers down here, these K sub 1s through K sub 4 factorials come from the different letters in the word Mississippi. So 39,916,800. That's going to be divided by 1 times 24 times 24 times 2. So let's multiply our denominator. Let's make that like a 9 instead of a 4. And that's going to equal to 1,152. So let's divide our 11 factorial by 1,152. And we get 34,650. Let's slide them back over since I don't need them no more. Okay. 34,650 distinguishable permutations. I know I spelled it wrong, but don't judge me. And there you go. So yes, it's important for us to understand the definition of a distinguishable permutation. Once again, distinguishable permutations is the number of ways you can arrange n items, where when you look at the items that are considered as a whole, they are distinct. But then when you look at them and group them into their subgroups, they're considered identical. And that's going to help us also answer question number 39. Because when you read question number 39, it says there are 10 gumballs left in a gumball machine where 4 are red and 6 are yellow. You put pennies until you empty the machine. How many distinct orders of yellow and green can come out the machine? So, matter of fact, I want to do this in a separate video. Let's do number 39 in a separate video. So we're going to call it ends to number 38. I'm indecisive. I don't know what I should do. You know what? How about I'll just